Okay, let's go down.
Okay, let me get that out. Hit the little minimize, yes. Okay, so this is the drill for today. You have a test next class. The test will cover sections 3.1 to 3.5, so it's all chapter 5, or all chapter 3.
Alright,
Okay.
so the top one, we factor out. How do I get some? Yeah, how do I get some? And then number 2.
It's still
And then we factor out -1, which like this, and it turns into x minus 2 over x plus 2 x minus 2. These cancel.
Technically, it's not a negative one there.
Okay, so we have a -1 over x plus 2. And then I graph this one.
You don't have to.
Okay.
I'm doing 2, so I should put 2 there.
Okay, so just let me get -1 for it.
Okay, so that's the limit. Everyone good with that? Of course, if you were doing this on a quiz, if you didn't write the limits as x approaches 2 from the right, I would have to take off. Yes? Okay. Sophie had a real good question. Sophie, I did, and I did correct myself and sent it. Sophia just had a really good question, and so her question was, how do you know it's from the right? In this case, since I can substitute that 2 in, the direction doesn't matter, but from the left to the right. Because what happens at that 2? If I were to graph it, what happens at that 2? Am I going to have a vertical asymptote, or am I going to have a hole? I'm going to have a hole. So it doesn't matter if I'm approaching from the left to the right, I'm going to approach the same number. So if that the direction doesn't matter. Now, if it was going from the -2, and the -2 is the discontinuity that's left over, I would have a vertical asymptote, then the direction matters. And we're going to talk more about that today. Okay, go.
The next one?
Next one.
So then we're going to go like this, x plus 3, x minus 3, these cancel, so x equals 3 is the removable, and then find the
What's
x
this x
value.
equals 3?
Huh?
What is that?
X equals 3. I don't know why it looks like that.
Why? What is that?
That's the removable,
Okay.
right?
Which the continuities are removable, and it's 3.1 is removable, and then the -3 will be non-removable, right? It's an aspect, it's just one to remove. Everyone good?
Six.
3.
Oh, yeah.
Because this one is x is equal to -3, this one is x is equal to 3.
So the x minus 3, that's still
So, well, actually, the whole is that x is equal to 3.
Yes.
The vertical asymptote is that x is equal to -3. Good? Good? Good. Any questions on the homework? And once? Twice? Okay.
We go over everyone's question.
Huh?
We go over everyone's question.
Yeah. Not enough on that one? So we already talked about what we're doing today, so this will be really your homework is going to be a review worksheet for the test.
this board says.
Okay, so today we're doing infinite limits. So you're going to determine the infinite limits from the left and the right, and then you're going to find and sketch the vertical asymptotes of the graph of the function. So this is kind of like a review of what we've already done from the rational functions that we did earlier. The only thing is now we're going to sketch the asymptotes, like which direction they go. Only other difference. So if I have this one, this is the first example on your notes. No, it's not. It's the first thing where you talk about an infinite limit. If you have an infinite limit, that means that when you go to find the the limit, you're either doing something like this, where your graph goes up and up and up, so this would be positive infinity, or your graph goes down and down, down, which would be negative infinity. That's what it means by infinite limits. Your limit is approaching either positive infinity or negative infinity. Not your C. Your C, this C value is still approaching a number. Does that make sense? It's still approaching a number. So if I look at this graph, if I take the limit of this function, and this is the graph of the function, if I take the limit and I'm approaching from the left, so here's the left, which should be a negative sign. Is it a negative sign in your notes, or is it a 1? Okay, good. So it's a negative sign. So I'm approaching from the left. So approaching from the left, I'm coming this way, and I drop straight down. That's why that answer is going to be negative infinity. And then this one, as I'm approaching 2 from the right, because that plus sign has a right, I'm approaching from the right, so I'm going this way. And that's why that answer, since it's going straight up, is infinity, which you technically should write positive infinity, but I usually just write positive sign. So when you say this, your limit still doesn't exist because I'm not approaching a number from both sides. I'm approaching the concept of either continually up or continually down, so I'm not approaching numbers, so the limit does not exist. So now some of your directions will say, find the limit or which one best describes the situation. And so you'll have you'll either be able to find the limit, you'll say the limit does not exist, or some of your choices will be positive infinity or negative infinity. These two still mean the limit does not exist, but you can say what the graph is approaching. Does that make sense? It's not approaching a number, it's approaching a concept either up or down. Good? What? So what are you confused by? Well, let's you have so if I look at this graph, and this is not on your note sheets, this is just a graph I came up with, and I asked you to find the limit from the left or the right. So if I say what is the limit in this, if I ask you for the limit as x approaches 1 from the left, what would you tell me the limit was of this function? If I'm approaching from the left. Positive infinity. Everyone good with that? Approaching from the left would be going this way. Okay, so that's left. If I ask you the limit, oh, why did I do that? The limit as x approaches 1 from the right of f of x, the function. Now I'm approaching from the right, so I'm doing this. It's still going to be positive infinity, right? So that's still going to be positive infinity. But if I ask you the limit as x approaches 1 without a direction, what would you tell me? Does not exist. Even though they're both approaching positive infinity, you might think it's the same number. If it's not a number, it's an idea. Good? Okay, so if I had, so to have a vertical asymptote, your function has to approach infinity or negative infinity as x approaches c from the right or from the left. And then the line x is equal to c is your vertical asymptote. So in order to have a vertical asymptote, as I approach that graph to whatever the number this is, the limit has to be positive infinity or negative infinity. It cannot be a number. So the one we just did here, I would have a vertical asymptote at x is equal to 1. This one back here, I would have a vertical asymptote at x is equal to 2. Good? You know that by graphing it. Now let's do some where you have to do some math first. So this one, I have this function, and I want you to find vertical asymptotes using the idea of limits to find vertical asymptotes. So I first have to find out where this graph is discontinuous. So I'm going to have to factor the numerator and the denominator, just like we did with rational functions. We just did those. So Nick, how would you factor the numerator? And then you're thinking about how to factor the denominator.
So it's 2x plus 3, x plus 2. Minus 5.
X plus 2. Okay, so everyone agrees with the factoring of that function, yes? Just to review from when we did rational expressions, this function is discontinuous. Where, Christian? Where else is it discontinuous? That would be a 0.
Negative 3.
Negative 3 has. You have to set this one equal this 2x plus 3 you set equal to 0. That's how I get the negative 3 halves. The x plus 2 you set equal to 0. That's how I get the negative 2. Subtract 3, negative 3. I just asked where it's discontinuous. So now we're doing what we did with rational functions. These would simplify, yes. So then this would be a removable. This one does not simplify, right? So it would be a non-removable. We already said before, when we did rational expressions, we already said that we knew that there was a vertical asymptote, but x is equal to negative 3 halves. We already said that, right? Right. So now what I want to do is I want to take the limit as x approaches negative 3 halves from the left, and I'm just going to write f of x because I don't feel like writing that whole thing over again. And then I'm going to take the limit as x approaches negative 3 halves from the right. And I want to verify that it's going to approach infinity or negative infinity. At this point, I'm probably going to want to graph it. Yes? So I have a choice. I can graph this whole thing, or I can graph what's left. It does not matter which one I graph. It'll be the same graph. It will be the exact same graph. So I am going to graph that. So this is what you get when you graph it. And I only graph what was left. So I get the same graph if I graph the whole thing. So when I go back here, my rough sketch. So as x approaches this negative 3 halves from the left it's going to be what? Positive infinity. As it approaches from the right, it's going to be negative infinity. Everyone good? Yes.
Could you explain what the why there wouldn't be a vertical asymptote at hidden numerator was how come there would be a second vertical asymptote?
Because this x is equal to negative 2. Because those simplify?
I'm just saying if x would be the only thing that I didn't write there, would it then be two vertical asymptotes?
Yes. So the question was, is it possible for a graph to have more than one vertical asymptote? And yes, it is. So if neither one of these discontinuities simplified, then you would have 2 vertical asymptotes. Make sense? Only the denominator, yes. If you set the top equal to 0, you're finding the zeros at the top. Okay? Moving on. Okay, this one, find the vertical asymptotes. Oh, that's not what you have? Oh, you have...
X cubed plus 1.
Okay. Yes, you do.
It's x plus 1 times x squared minus x.
Go ahead, Joe.
X plus 1 times x squared minus x plus 1. All over it. And then you just get the polynomial.
So those will simplify. So it's discontinuous at x is equal to -1, but that's removable. Everyone agrees? So since it's removable, there are no vertical asymptotes. The only thing this graph is going to have is a hole.
How do we know?
How do we know what?
Oh, I thought it was since it's perfect. What is the what is it called? Addition.
This is the sum of two perfect cubes. That factors as the cubed root. The sign stays the same, so if this is a plus, it stays a plus. Then you do a squared minus ab, and then always plus b squared. If this were a cubed minus b cubed, this would be a minus b, because that first sign stays the same. A squared, now that sign changes, and the last sign is always plus.
I remember that. So there's no vertical asymptote. Oh, everything is denominators.
There's no vertical asymptote if you do not have a discontinuity that's not removed. Huh? So this technically, like when I'm approaching, like when I'm going up, that's like an unbound behavior because it's not bound. It's not going to stop. It's going to keep on going.
So it occurs for
So it occurs in vertical asymptotes. I don't. Okay, so these ones, I know it's just, the first one, I know it's discontinuous at x is equal to -4. I'm finding the limit as x approaches -4 from the left. So I know since that -4 does not simplify, I'm going to have some type of vertical asymptote. I don't know whether it goes up or down. Do we all agree that we know that? So in order to figure out whether it goes up and down, what am I going to have to do? Graph it. So I'm going to have to graph this one, and then I'm going to have to graph them all. Does that make sense? Yeah. So I'm going to graph them all. I'm going to give you a minute to graph them. Then I'm going to pull one person up here who's going to do a rough graph of the sketch and then find the limit. Notice that you're only doing one direction. Like this one's from the left, this one's from the right. You're only doing one direction. One direction. And now.
So you graph it, and this is a. So this is from the left approaching right, and as it goes from the left, it goes down. So there's
Everyone good? All right, Brett, now go. For one like that, yes. So for one like the A on the test, it's going to tell you to make the sketch too. Does that make sense? It's just why it says final limit. So depending on the directions, this one says just final limit. That is a beautiful graph.
I don't know if I just have fat fingers or what.
Your fingers are fine. Don't body shame for your fingers.
Because it keeps erasing when I'm just touching it.
Okay.
I don't know where the pin is. There you go. So
All right, on this one. So Brett, what is your limit as x approaches 3? How'd you get 1/6? I agree. How'd you get it?
just something free because he said it wasn't like strictly.
Yes. So there's no discontinuities to that one, right? Because if I take that 9 plus x squared and I set it equal to 0, x squared would equal -9. That can't happen. So there's no places where that function is discontinuous. If that 3 is not a problem, which it's not a discontinuity, he can do direct substitution. He originally started with 3/18, reduces to 1/6. Good? If the 3 was a problem, then you would have to graph it and see what happens. You with me? Okay, the next one, C, Ryan, I believe that's you.
What are you saying?
Okay, so if I ask you a whole bunch of questions, because I like asking you a whole bunch of questions, the 7 is what kind of discontinuity? Removable, and then what is your other discontinuity?
The -5.
-5, and that is
None.
non-removable. So does this graph have a vertical asymptote?
Yeah.
Where is it?
-5.
-5. Okay, since the 7 is what you're trying to find a limit, it simplifies so you can do direct substitution. That's how you get the 7/12. Everyone good? Notice that this one did not have a direction left or right. So if I asked you to find the limit of this one as x approaches -5, I know there's a vertical asymptote. So what would you tell me if it's just -5 without a direction, without a left or a right? Does not exist. And if you're approaching a vertical asymptote when you're taking that limit and there's no direction, then the limit does not exist. You good? At -5, not at 7. Right? Yeah, because you have to be careful. All right, and then Jeff.
There's like 5 there.
What?
Am I like talking what I did?
Sure.
Okay. Alright, so first you graph it. And then and then you're going from the right, following this, going down. So then we're gonna something like a negative infinity, and do you want the vertical asymptote?
You said that's the vertical asymptote. Would you like to show the vertical asymptote?
X equals -5.
Yes, x is equal to -5 would be the vertical asymptote. Remember, if you are asked for the vertical asymptote, you have to give them the form of an equation. You can't just write -5. It has to be x is equal to -5. Because it's not. It's a whole line. It's not just a point. Everyone good? Okay, the next one talks about, the next slide is about properties of infinite limits. So what this is saying is if I find the limit of f of x as x approaches c, it's positive infinity. Okay? If I find the limit of a different function, g, as I approach the same number, it's L. This is some constant, like 2, 3, -5, well, let's make it positive, 2, 5, something. It's just a number. Does that make sense? So if I take the limit of f of x plus or minus g of x, so I'm taking so this limit of f of x is infinity, and I'm going to add or subtract a constant, like a number. What's that going to end up being? What's infinity plus 3? It's still going to be infinity. Does that make sense? Because adding that constant won't change infinity. And if it happened to be negative infinity, adding that constant will not change negative infinity either. Make sense? So number 2, if I take f of x, so I take infinity, and I'm multiplying it by L, what's that going to be? That's going to be positive infinity if L is greater than 0, right? What's it going to be if L is, what is infinity if L is less than 0? What's it going to be?
Negative.
It's going to be negative infinity. If I multiply by a negative number, it's going to make the whole thing negative. And then if L is 0, what happens? It's going to be 0. So that one you have to kind of think about a little bit. Huh? Yeah, I did it all at once. My bad. And then the next one, if I take a constant, so I take some number and I divide it by infinity, what's that gonna equal? What's 3 divided by 1,000? Then 3 divided by 10,000, and 3 divided by 10 million, huh? Very small number approaching what number? 0, approaching 0. Doesn't matter if infinity is positive or negative, doesn't matter if the constant is positive or negative. If you take a constant and divide it by a larger and larger number, you're getting closer and closer to 0. That's not hard, right? And then the last one, similar properties hold for one-sided limits for a function. So technically, what you should be doing is I should be looking as x approaches 1, I should look at this part first. Are you with me? And that's going to approach, since I know it's a vertical asymptote, do we agree it's going to approach positive or negative infinity? Not sure which one. I'm going to just write myself a note. That's going to approach positive or negative infinity. And then when I look at this guy, 2x, what's that going to approach if I substitute 1 into that? 2. So I'm going to have positive or negative infinity plus 2. So is that 2 going to have an effect on this problem at all? No. So in order to find the answer to this, I'm going to take this guy and put it in my calculator and see what the graph looks like. I could put the plus 2x in if I want, but it's not going to affect the problem. And it's this, right? Oh, but it's up to, okay. More or less like that? So as I approach 1 from the right, so I'm going this way, what's it going to be? So this is going to be positive infinity, so the whole answer is going to be positive infinity. Does that make sense? Okay. I am giving you, so then I have a note to myself. We covered intermediate value theorem last class, did we not?
Now they're like,
Yes, remember the speed of the car?
Yes.
I know.
Oh, yeah.
We did. It's at the end of your last note sheet, yes? I'm good. All right, I'm passing out the chapter 3 with you. This is your homework for tonight for the test on Tuesday.
it just don't went out.
All right, so this one's saying the limit as x approaches 2 from the right is negative 1. So here's 2, right? So this line here, I'm going to just draw a little highlighter of 2, because that's x is equal to 2. Everyone with me? As I'm approaching from the right, so as I'm approaching from this direction here, it's telling me that my limit is negative 1. So I should be down at negative 1 here. Does that make sense? I'm just going to put myself a little dot there to remind myself, yes? And then it tells me as I'm approaching 2 from the left, it should be 3. So up here, I should put a little dot here. So from the left, as I'm coming this direction, I should be hitting there. Then it tells me that f of 2 is equal to 0. So I know that, I can put that there. Which means this has to be an open circle, and this has to be an open circle. If they are not open circles, then you no longer have a function. It no longer passes that vertical line test. Then, for fun, I thought I would do as x approaches 5. I added that, because why wouldn't I have some more fun? 2, 3, 4, 5. As I approach 5, the limit does not exist, which means I cannot just draw a line through that 5. I have to either go up, go down, or have some type of jump, right? Because those are the 2 times that a limit does not exist, is when you have a jump or when you have an asymptote. Yes? When does the jump happen? What type of function? Someone said it. Piecewise function. So if you have a piecewise function, you have to check for that jump. If you have the rational expression, which is the numerator and denominator, then you may have a vertical asymptote. So I said, I'm going back here, I have no other restrictions to the left of this 2, right? So my line can go anywhere. Doesn't matter where it goes. It can go like that. If I want to go like that, I can go like that. If I want to go like this, I can go like that. It does not matter, right? As I'm approaching here, I got to stop at negative 5, but I can maybe, and they didn't erase it. Why did they do that? So this is an open circle, and let's say I make that an asymptote. And then let's say I just do something else. And let's say I go like this. Before I hit submit or before I turn it in, I need to make sure that it passes the vertical line test to make it still function. Which means anytime I draw a vertical line, it should only intersect my graph one time. Yes? Was that terrible? Not really. Yes?
You need the line on the right side, right of the.
Technically, no, you don't. But, I mean, I guess you could leave it like that and not put anything. That's fine. Or you could write something like this, too. It doesn't matter. Huh? This technically is a jump. So this would be a piecewise function. With, it would be... Oh, I could have done that, too. I didn't even think of doing it that way. So let's say I did make this, so maybe I go like this, and then I have an open circle, and then maybe I have a closed circle, and I do that. It can be a jump too. Vertical asymptote for jump. As long as, and then you go back and you make sure that you met all these requirements. Yes? Yes, I can. Any other questions? Oh, wait.